Let's bring up Sven, our CTO. So James just mentioned and talked a lot about exascaler. Now it's time to talk about the next generation, Infinia.
Good afternoon. My name is Sven. I'm DDN CTO, and I would like to talk a little bit about Infinia. Infinia is a really interesting project. We started this about 7 years ago, and we took a very different approach on how we get it to market. So instead of just GAing it, we basically picked a couple of very large-scale customers. We have actually a system right now that is being tested at about 1,000 nodes. That's a pretty large-scale system, almost an exabyte in size. And so I want to talk to you a little bit about, why did we build this, what is it providing, and what are we going to do with it? So modern AI systems, James did a really great job showing you what customers do today. And where the train is going in terms of scale and everything, but there is also a very significant change in how applications are interacting with storage systems in general. So what you see these days are much, much more complicated use cases which touch different aspects of storage. And when I say storage, storage is kind of a loose term because what is actually storage? Is it the data, or is it the metadata that is associated with the data, or is it a combination of both? Or maybe even some today typically handled external entity like a database where some additional informations are stored inside the system. And so what we're seeing is, and we've seen that for a very, very long time, is that there really is a convergence of these worlds. So customers have such complex workflows that they typically have the need to get some information out of a database. They need to get some data extracted out of the data that they're collecting, so you enrich data over time. And then particularly in the use case that you see here, which is kind of a rack use case, you see that there is many, many different touch points for very different types of storage. So at the end of the day, the user at the top here, he's asking a question in a rack session, and then there is a lot of different pointers that you see in different directions. So on one hand, before you can answer this question that is enabled by rack, somebody had before to take a bunch of text, streaming, images, all kind of information, essentially process them, put some of the informations in an object store, some informations go into a key value store, some other things going to go into a vector database so you can actually find things much, much quicker in order to answer a real-time response to a rack question. And then at the end of the day, the whole point of this is data intelligence, and customers want to get something that is actionable out of the system. So in order to enable these type of workflows today, as I said, customers are using a lot of different things. There's vector databases, there's key value stores, there's objects that are just mentioned here on the slides, but it's typically much more. In some cases, it's relational databases and so on and so on. So I want to drill in a little bit into all of that. So what is Infinia really? So Infinia really is a data intelligence platform. It is really not a storage product as in the traditional definition of a storage product where you have a couple of gear running somewhere in the rack, somebody mounts a file system, or somebody interacts with it with an object store interface. It's a lot of different interfaces that are required to provide a data intelligence platform. And so basically you have the S3 object interface on the top left. You also have things like CSI and Cinder, because a lot of these applications run, for example, in containers or virtual machines. So somehow you need to provide storage for them too, if they're part of the overall workflow. And then you have, obviously, the more traditional file system interface, which a lot of people use at very, very large scale today. For one reason is because most of the applications today in this space run on file systems. Even there is a massive shift towards object, there is still a lot of models and products that have been developed over the last decade or so that are typically using file system interfaces. So you really need to provide object, you need to provide some block, you need to provide some file. Another thing that is becoming more and more useful, and you will see this when I drill into some more of the examples that we're trying to support with the platform, an SQL interface, type of interface to the same data is also quite critical because it's the way to essentially reduce the amount of data that you potentially have to process or look into. And again, I'm going to go a little bit more into the details to that. So all of these capabilities in Infinia are essentially implemented on top of an abstraction layer. The abstraction layer is also something that we're going to provide in form of a software development kit So customers can actually write their own application, their own data services interface, which is simply using our SDK mid-layer infrastructure to build and accelerate your own applications. But that's a session for a different talk. So the features that are embedded in the product are, we need to be able to do tag and search. So this is really, you have objects, they have significant amount of metadata associated with it, and you want to find data by metadata, you want to add lots of metadata to the system. We really designed Infinia to be not just a normal object store. It puts a massive focus on scalability of metadata. And for each object in the system, you can attach tens of thousands of metadata attributes that you will later use in your workflows to either find data or further enrich data by updating essentially metadata tags to it. It's a highly multi-tenant system, so it allows you to really put a massive amount of infrastructure in your data center or into a cloud infrastructure, and then divide essentially up the space and the performance of the system across multiple tenants. Different than most other storage systems, it actually doesn't use any form of physical allocation of space. It is really a credit-based system, and it essentially provides SLAs to the individual end users for performance, as well as SLAs on a capacity basis. And you can technically build up a large system. You can board Coke and Pepsi on the same system. They don't see each other. They each get their own SLA for performance, own SLA for capacity, but it uses one very large-scale system to provide this. So the product is also very attractive for service providers because it allows you to basically manage a very large-scale system, which is much, much more efficient commercially, but then still provide SLAs for individual end users that are consuming the system in a shared way. The product provides quality of services, so we can also provide QoS for individual applications. So if within Coke, somebody says, hey, at the end of the month, finance needs to run a very specific analytics job. It's super critical. It runs once a month. You can dynamically tell it all performance goes to this finance application. When it's finished, it goes down. While it's running, everybody else get whatever remaining resources are available. But as long as it's running, it's going to get top priority. And so the prioritization and quality of service is really per individual application or bucket, and can be basically delegated down from the tenant to its subtenants and then to individual application level. It's a cloud-native product. Infinia is a pure software product. We bundle it together with hardware as a reference architecture, but the software has been completely developed as a software product. And in version 1, we bundle it together with a reference architecture, but going forward, we already have plans with all our partners out there to basically build reference architectures with different server vendors, and eventually we plan to also offer this as a pure software-only offering, which we already do with a small number of very, very large-scale customers. But it's critical to understand it's a pure software product, so integrating this into the clouds is very easy. We already have a system up and running at GCP, which we use for our own testing on the cloud, and so we're going to board this on all the major clouds and make it available for end users. I touched on this briefly already. It's really built for very, very large scale. It's a pretty big lift, I can tell you. If your first customer where you're deploying this runs this on 960 servers with almost an exabyte of capacity, there is very few version 1 products that come out that go immediately to the step of that scalability. So it was quite challenging to get this all working and up and running, but we really did. And so from a scalability point of view, we have very little worries. We believe it's going to scale very great and will deliver also everything in a very elastic way, because we can basically add individual nodes into the system to scale it, and the system has built-in capabilities to not just expand the system, but also reduce the system. So it's something that not every vendor thinks about or builds in, because if you look at a large-scale system, particularly at the sizes I'm talking about, you basically have to constantly refresh hardware and add hardware to it. But that also at the same time means some of the older hardware actually needs to be taken out of service. And so in order to do this, you need to have the whole workflow where you can add resources and remove older resources out of a running system without actually ever taking it down. And I don't need to mention this, or it's not on the slide, but I should probably mention it, is the system is, everything is online upgradable. So there's no downtime required for adding capacity, removing capacity, or even going from individual software versions to another. Everything is online, and the system is automatically coordinating all the updates. So a couple of examples on some of the value that Infinia provides. So this is about the essentially data intelligence enablement, which is what some people refer to when it goes around preparing the data for training. So when you look at how customers trying to do this today, data input comes from lots of different places. Some is in their local lake houses, so data that they've stored on-prem. It might be even in multiple different systems. There may be an object store, there may be a file system solution out there that they're using. We see customers who have other data sets that are public, so they store data in GCP or they store data in AWS or in any of the other public cloud providers. And then typically what the customers want to do is they're going to run some distributed frameworks like Spark or Ray that is basically running on a large number of GPUs in order to do this. So what Infinia provides today is that Infinia itself can essentially be a lake house on-prem. It provides already an object interface. In version 1, it has a block interface for providing CSI and Cinder clients to connect to it. But we're also in the process of enabling our POSIX file system client, which will allow parallel file system access to the same data. And it will be shared access between object and file. So the file part, as I said, is not a today feature, but it's something that has been actively worked on for the last 3 years and something that we plan to launch next year. There is also a feature that is being worked on, which we plan to demo by the end of this year and will be available early next year, which is called remote bucket or remote data source support. So what that allows you to do is essentially you can point an Infinia system to an existing data set. And so Infinia is going to go and basically pull all the metadata into Infinia. So now we know what data is actually stored somewhere else, but it's locally available wherever the Infinia instance is running. So now you can use all the rich interfaces like querying through SQL or using the REST interface in order to identify data. And you can instruct Infinia exactly what data at what point in time you want to actually have either a cached version or a physical copy of the data inside the Infinia instance. So the other interesting thing is, given that we have a clone, so to speak, of the metadata, you can now run processing on this data, further enrich the object metadata locally in the Infinia instance, because lots of other storage systems have massive limitations on metadata. If you go out to AWS, for example, you can store like 20 tags or so on an object, and then you kind of run out of metadata space. As I mentioned before, in Infinia, you can have tens of thousands of tags attached to an object. So you can use Infinia essentially as a much more richer repository to enrich your data, add massive amount of metadata and descriptive information to it, and then use the search capabilities inside in Infinia to essentially find the information that you really care about. So this will obviously enable you to run, given its scale and performance capability, to run across thousands of GPUs. And so essentially you're going to have one unified platform to run data analytics as well as some of the AI pre-training for data preparation. Large language model training. It's another workflow or use case that obviously our customers are doing today. Here they want to use a lot of different loaders of data. It's all about data transformation, getting into a system in order to train on it. And so, as I said initially, this is just a list of some of them. There's obviously much, much more out. I just want to provide a couple of examples here. And so the key message here is that in order to load data into the system, you typically use one of these or some of the other loaders out there. But basically, the information is being transformed and then needs to be somehow ingested into the storage system. And so by enabling our native library support, so this is the SDK I mentioned before, we're in the process of transforming these different loaders to, instead of using a much lower performing protocol, to use our native SDK protocol to communicate directly with the storage system itself. So we've seen in some of the workloads, like if you use Spark, for example, and we have a Spark backend implementation for Infinia, ingesting data with Spark can give you a 10x improvement if all you do is basically use your existing Spark application, don't change anything on it, just replace the backend driver for Spark, how it communicates with the storage system. So there's a lot of enhancements that we're doing on multiple of these different ecosystem environments in order to improve the performance. And so if you can now think about, we have all the enablement for these different data loaders, you can actually add remote data sources to the system and provide this all through a high-performance S3 interface. It's really a game changer for distributed training, particularly at very, very large scale. And if you have diverse data sources or sources that are spread across the planet potentially. I mentioned in my very first slide, the example of a RAG workload. So there's lots of different steps involved in order to do this. So I mentioned this at the very beginning. One of the first things you're going to do is you basically upload lots of data into the system. So in order to upload the data into the system, you need to use some interface. This could be a parallel file system. This could be an object store interface, so for example, S3. And because in Infinia we have the SDK and we have essentially database type capabilities into the system, our internal engine is able to absorb a very, very large number of metadata informations at the same time. So it overcomes some of the limitations of POSIX, for example, where if you ingest data in the same directory, there's lots of locking and overheads implied by using that interface. With S3, it's highly parallelized, but it doesn't necessarily have the same consistency like POSIX has. And so in Infinia, you have the benefit that you can use different types of inserts into the system, and each application by itself essentially can dial in what level of consistency is required based on the API calls it uses inside Infinia through the SDK. So you basically input a lot of these data informations, the data, you get them from lakehouses, private data sets, public data sets. You do the computation on it, you move the individual pieces in vector databases or wherever they need to be. And so with Infinia, you can basically do all of those things outside the compute space in one single platform and basically pull all of these different things together in one single system. So here's an example on how we did this or doing this with Spark. So essentially you have the Spark application on the very top. So as I said, the end user itself doesn't have to change anything. You take an existing Spark app as you have it today. All you need to do is you change one line in Spark that defines what is the backend driver used by Spark. By default, it's either POSIX or it's S3. So we give it a third option, which is essentially an Infinia SDK. So now if Spark actually performs any operation on the data, it gets intercepted by our Spark acceleration library. And so Infinia is essentially the thing that opens the data sets, reads files, writes files, does all the I/O, performs all the I/O calls. But because we're moving all of these capabilities directly into the application, it actually gives you a couple of very interesting benefits. So number one is we do all the data reduction and encryption, for example, directly in the application itself. So if you write data out of Spark, we can compress data, we can encrypt it, and then we send the data over the wire. The reason this is very critical is because if you send data encrypted from the client, you can't actually compress or dedupe it anymore, because it's just all random garbage numbers, and so there is no way to actually extract anything out of it. So it's very critical to have the right order of how you do data reduction and also encryption of data. All of these operations happen in user space because Infinia runs in user space and the SDK set provides all these capabilities in user space, which also eliminates user space and kernel transitions. So given your application runs in user space already, you can have things like shared memory buffers where the application and Infinia basically use the same buffers. The application writes into an Infinia-owned buffer, and then Infinia can just send the data via RDMA out over the network. So it's much, much more efficient data transfer. And on top of that, given that we do client-side operations, that also means erasure coding happens inside the client. The reason this is very critical is traditionally storage systems send data from the client to a storage system. Then the erasure coding essentially generates east-west traffic. So if this is all a single appliance where it happens inside the appliance, the customer doesn't see that. If you operate at a very, very large scale, like an Infinia system where the clients and the servers are communicating over an RPC protocol, it means that there is east-west traffic happening between the servers. And by doing this client side, we can completely eliminate that, which means we essentially preserve the same coolness that James already mentioned on Exascaler, the intelligence is on the client knows where the data needs to be written, the client knows where the data needs to be read from, and essentially Infinia provides the same capabilities, but in a more software-defined way with a couple of enhanced capabilities that are desired, particularly by enterprise customers as well. So in summary, we've seen for some of these workloads, there is very significant acceleration, particularly for some of the RAG workloads that we've tried out, by essentially putting all of those features into one single product, and you can basically support the workflow end to end, embedding the objects, embedding some of the vector database pieces, providing SQL access to the system, essentially providing volumes for container services. You can have this very nice loop of where people ingesting data, it gets stored on Infinia. There is additional computation happening that further enriches the data. It writes the new data that has been extracted from the data back as metadata, which can then be used as tags in order to be searched, in order to basically, by the microservices to figure out what is the data sets that I'm actually really looking at, and how do I integrate that into my response to the end user, particularly in a RAG session, for example. And all of that with what we always call below the stack enhancements, which we already mentioned. We have a very, very dense system. We can reduce significantly power, density, and therefore floor space. And so we believe we have an incredibly cool package here that will allow us to accelerate your workflows. So quick summary chart. So easy leverage, cost advantage anywhere and anytime. So Infinia will be able to be deployed on-prem. We're doing this already at very, very large scale for a handful of selected customers. We believe we can easily handle very, very large scale. As I said, we're already deploying at almost an exabyte in size. We've seen, compared to other object stores product, massive acceleration in performance. I have a couple of slides I'm going to show in one-to-one sessions with customers this week, where we can show millions of objects operations per second out of an object store at latency in the single-digit millisecond range, which is very, very difficult for an object store product. With obviously the benefits of an object store, given that everything is massively distributed and highly resilient. You have very, very high uptime with these systems. There's a lot of very fault domain enablement capabilities in Infinia. One of the tests we've done at our large-scale system was we've done essentially a performance test on the system. And while everything was running, we simply killed an entire rack of hardware. So this is 480 drives that went offline at the same time. And the system basically had a short I/O delay of about 10 to 15 seconds, and then everything continued. And so the end user application never saw a single I/O pause or a single I/O error in general outside of those 15 seconds delay until the system figured out all the pieces that were down. So there's very high resilience built into the system as well. And then in the cloud, we believe we're going to be able to deliver a much, much higher performant object store offering than it exists in the public cloud vendors domain today. Also, we believe we can deliver very, very high scale for a particular entity. You don't need to use a shared object store. You're going to have your own private object store if you want, with very, very high performance. And we believe at the same time, we can also, based on how we pick and choose where the data is stored, provide some cost savings at the same time. With that, I'm concluding my talk.
Thank you, Sven.